Hi students, in this video we're going to look at how to anti-differentiate power functions. After watching this video you should be able to establish and use the formula given there to anti-differentiate power functions. We're also going to talk about how when we anti-differentiate functions or sums of functions, we can just integrate each part of the sum separately to anti-differentiate our functions. Big things to remember. So anti-differentiation is the reverse or inverse of deriving. When we do carry out anti-differentiation, we also call those indefinite integrals. We always need to include a constant of coefficient there. Last thing to remember is our derivative of the power function. So when we derive a power function, x to the n, the derivative is that power, we multiply by the old power, and then that power goes down by 1. Right. So using that rule, we can differentiate a simple function like 2x squared. So f dash x is going to equal that power of 2 goes to the front, and then that power goes down by 1. So that's 2 times 2, which is 4, and then x. And so if we want to anti-differentiate that, we will need to apply similar sort of steps, but just in reverse. So if we've got our integral here of 4x dx, that's going to equal, well, we'll start off with our function. Now, the last thing we did was subtract 1 to the power. So we need to add 1 back onto the power. So it becomes x squared. Before that, we had to multiply by 2. So instead, we have to do the reverse or the opposite, the inverse of multiplying by 2. That 2 came from the power up there. We have to divide by 2 instead. And when simplified, 4 divided by 2, that's 2x squared plus our coefficient of integration. And so those are our steps then for determining the antiderivative of a power. So if we've got our general case of x to the n, f of x, which is our integral of x to the n dx, remember x is the variable we're looking at, we are going to add 1 to the power. Rather than take away 1 from the power, we'll add 1 to the power, and then divide by whatever that new power is. And then don't forget your constant of integration. And that's our rule for determining the antiderivative of a power function. All right, so let's do a couple of simple examples. If we've got f to the x here, okay, capital F of x is going to equal the integral of 3x to the 5 plus 2x minus 8 dx, which equals, that will become, now when we have multiple parts here, we'll just do each one at a time and integrate each one according to the rule. So we start off with x to the 5, that will become x to the 6. Then we'll divide by that new power, so divide by 6. Our next term will be 2x squared, divide by that new power, that's 2. Now for the 8, there's no x's on it, or in fact you could say that it's got, that's 8x to the 0. So when we add 1 to the power, it will become 8x to the 1 divided by 1 plus c. And when we simplify, 3 over 6 is just half, so that'll be x over 6. So x to the 6 over 2 plus 2 over 2, those just cancel to x squared. We don't need a denominator of 1, so that'll be plus 8x plus c. So there's just our power rule. Add 1 to the power, divide by the new power, and then simplify as you go. If you have a constant, sorry, that should be a minus 8x there. My bad. If you have a constant, just add an x onto it is the simplest way you can think about it, or you can apply the rule. That's shown there. All right, let's go with b. So b, this one has x squared in the denominator, so we're just going to rewrite that as 5x minus 4, x to the negative 2, and our integral is just going to work out exactly the same way. This time we're determining capital G of x, because our function was g. So that's 5x minus 4x negative 2 dx. That'll become 5x squared over 2. Subtract 4. Now x negative 2 plus 1 will be negative 1 divided by negative 1 plus c. 5x squared over 2 can't really be simplified, so we'll just call it 5x squared over 2. Now negative 4 over negative 1 becomes positive 4. X to the negative 1 I can just put on the bottom of that fraction. And there's that second one there. All right, last one. Hx equals 6 plus square root x. Again, with that square root sign, we can rewrite that. So x plus 1 to the half. And so our integral, capital H, our antiderivative, h of x, is going to be my integral of 6 plus x to the half dx. So that'll be 6x1 over 1 plus, now 1 plus half will be 1.5, or 3 on 2, over 3 on 2. So that'll just become 6x. And then my denominator in a denominator can come to the top. So plus 2x to the 3 on 2 over 3. Can't forget my constant of integration there, plus c either. So guys, just using that power rule there, expressing anything in a denominator with a negative power, any roots as fraction powers, and the power rule for anti-differentiation should be pretty straightforward. So after watching this video, you should be able to anti-differentiate power functions. That's basically that first one. And also, if you've got multiple functions just added together, just recognize we can find the antiderivative by anti-differentiating each part one at a time.